Ankit, Joyita, and
Yes, sir.
Kashyapi.
Sir, we can start the discussion voluntarily. Only 21 student is there. So can I call the name voluntarily, those who are present here? It will be okay then.
It's okay, but I have seen that few students not raising hand or not giving the presentation. So
Yeah, so
they should
because in
participate.
mobile we cannot have that button actually, that raising hand button.
Okay, okay,
Yes, sir.
no problem. But
Okay.
I'd like to request all of you to please then participate
Yes, yes.
voluntarily.
Okay, sir.
Okay. So please, I'm handing
Okay,
over
sir.
this to Ankit. Joyita, Kashyapi, please.
Okay, so good morning. Good afternoon, actually. Good afternoon, everyone. So today discussion topic is about feature selection. So I will start first. Jara, it is visible, my PPT.
Yes, it's visible.
Okay, so let's start the discussion. So today topic is about feature selection, and we will also discuss about the sequential forward and backward algorithm. So I have covered these topics, including the curse of dimensionality, how to overcome it, and feature selection, what is the evolution, and supervised, unsupervised. Then I will discuss about the SFS and S. So extract features. So the first thing come to our mind is collect the information from the target, right? See the line that I have highlighted with red color. That is more features is better for more information. Uh, but this does not work all the time, isn't it? Because some features may irrelevant and may also have redundant feature. And if the features do not provide any additional informations, then the performance of the learning algorithm will be degraded, right? Then this is what we call dimensionality with the data mining. Both the concept is same, but the definition will be different. Fine. So here, what is we can see the graph that the classifier performance usually degraded for a large number of features as we consider a large number of features. Then what happens? The performance of the classifier is degraded, right? So what, how to overcome it? To overcome it, this curse of dimensionality, what we do features reduction. So there are two types of features reduction, that is feature selection and features extraction. So today we will discuss about features selection. In the selection, what we do, we choose the best subset. Okay, like you can see that from F there is till x1 x2 till xn there are features. These are the features. Okay, then what we'll do, we will choose the best subset. Like here F subset, F dash is the subset of F. Then we will collect the best features from the particular subset, which is features that is available, okay, from the superset. Fine. So why we do so? So it to optimize it, right? To optimize a certain criteria. Optimize means it to either improve it, isn't it? So there is one more thing, is that if there is n number of features, what will be the number of subset? 2 to the power n, isn't it? So and we cannot do we can't enumerate all the possible subset if it is 2 to the power n. So what we need some method, need of the method. There are methods are like optimum is there, heuristic is there, randomize is there, right? And we will discuss about the heuristic today. Okay. Now the evolution strategies. See, there are two types of evolution strategies. Fine. First, there is known as unsupervised, and another is supervised. So unsupervised is also known as filter method. Here, what happened actually, we do not evaluate the subset over the training examples. We evaluate the information content in the unsupervised method. Fine. I will explain it with diagram. Just remember the definition first. And in supervised, it is also known as Webber method, and the web subset used on the learning algorithm. Okay, see the diagram here. First thing that feature selection is an optimization problem, right? We have a search algorithm and we have objective function. See the diagram here. We have objective function, right? We are trying to optimize the function. Yeah, and the search in the search algorithm, what we do first, we select the feature subset. Okay, after that we score it on the objective function, then find the goodness of the feature subset, and based on these it will decide which part of it we will explore. Then we will get the final feature subset. Then this is used by the PR algorithm. There is a pattern recognition algorithm or machine learning. So here you can see the both the unsupervised and supervised together. So the working mechanism is same. So in filter, what will happen? It will score it will select the super feature subset and score it on the objective content as a information content, and based on this we will use the final feature subset by the machine learning algorithm. But in the wrapper, what we do first, the feature subset, we collect the feature subset, then we use the machine learning algorithm to predict the accuracy. Fine. After predicting the accuracy, we get the particular features, final features. Then after that, we use this final feature subset in the PR algorithm. Fine. So now it is about sequential forward selection. So first, what happened here in the forward selection, it start with empty features set. Fine. Then we try to remain. Then we try each remaining features and estimate it by classification or regression error for adding each features, and select features that give maximum improvement and stop when there is no sufficient improvement. Fine. See, you can see the here documentation. Here it is written that start the empty set with why not. Fine. Why not conditional? Why? Because the start, because it start with the empty features set, isn't it? Here we are choosing the best features, and we maximize it both in, we should remember both in forward selection, backward selection, we both in both here we do maximization. Fine. And here yk denote the k features that already we have selected. Fine. So we can decide the when we add the value yk, when we add the value to j, then it will increase the maximization. Fine. Also write yk plus 1, also write that yk union to x1, x2, x3, like this. Why? Because this is the difference feature we will find. Why forward is used? Because forward word is used because we are, what we are doing actually here in the sequential forward selection, we are adding feature, right? We are adding feature sequentially at a time, right? So in the sequential backward selection, what we do first, is at the starting, the set is full, feature set is full. Fine. And what we do, we try to remove the some features, and after dropping the features with the smallest impact, we have to drop the features with the smallest impact and error. So there is y cap minus x is there, right? If we see, one more thing is that as I told that in both sequential forward selection and sequential backward selection, what we are doing, that we are maximizing, isn't it? We are maximizing. And if here also yk minus x is there, because we are removing the features. from the selected the features is not empty feature set is full. From there we are removing it, right? We are removing the features, then the value of the gem must not reduce that much. We must keep in mind in that. So I have gone through some papers there. I have got that sequential backward selection is far better than sequential forward selection. So I'm not saying that I'm not making the statement just the work, because both have disadvantage and lots of generalization have been done. Okay, why it is better actually? Because here from existing features we are selecting one and we are reducing which is not importance, right? Which features is not providing us the additional information, so we are reducing that, isn't it? So what we are taking interdependency about more and into consideration than in forward selection. So thank you.
Good afternoon, everyone. My name is Kashyavi, and now I'm going to present on the topic feature selection sequential algorithm. Mari?
Yes, you can
Yeah,
share.
yeah, I'm sharing. Yeah. So at first, we'll go for the introduction. So what is feature selection sequential algorithm? So feature selection methods are intended to reduce the number of input variables to those that are believed to be most useful to a model in order to predict the target variable. So in other words, feature selection is primarily focused on removing non-informative or redundant predictors from the model. The implementation of sequential feature um, algorithm algorithm are a family of greedy search algorithms that have been developed as a suboptimal solution to the computational after not feasible exhaustive search. So these are used to reduce an initial d-dimensional features space to a k-dimensional feature subspace where k is less than the d. The motivation behind this selection algorithm is to automatically select a subset of features that is most relevant to the problem. So now there are two variants of feature selection sequential algorithm. So the first one is sequential forward selection. So in sequential forward selection, at first, the best single feature is selected that is using some criterion functions. Then pairs of features are formed using one of the remaining features, and this best features and the best pair is selected. So in this, features are sequentially added to an empty candidate set until the addition of further um, feature does not decrease the criterion. So the next is the sequential backward selection. So in this, features are sequentially removed from a full candidate set until the remove of further features increase the criterion. So that's it. Thank you.
Good afternoon, everyone. My name is Jyoti Bora, and I'm from 9th. So let's start. Just wait, I'll be sharing my screen. Kashavi, is my screen visible?
Yes, yes, it's visible.
Okay. So today's discussion topic is about the sequential forward or backward selection algorithm. So this algorithm are mainly feature selection algorithm. So firstly, what is feature selection? So it mainly feature selection is mainly selecting of the features that is actually required. So mainly when classifying novel patterns, only a small number of features are needed to be computed. So thus it helps in faster classification. So why actually this feature selection is performed? Because data interpretation and knowledge for data interpretation and knowledge discovery. So there are two ways. So firstly, the sequential forward selection. So here, firstly, empty features from empty feature set, it is from full feature set. So it mainly is best for the optimal when optimal subset is small. So first, the best single feature is selected, that is using some functions. So then pairs of features are formed using one of the remaining feature, and this best feature and the best pair is selected. So next, triplets of features are formed using one of the remaining features, and these two best features and the best triplet is selected. So this procedure continues until a predefined number of features are selected. So in SBS, the sequential backward selection, first the criteria function is completed for all n features, and then each feature is deleted one at a time, and the criteria function is completed for all the subsets. So this procedure continues until a predefined number of features are left. So actually, I didn't show the algorithm because I didn't understand it properly. So that's it. Thank you.
Good afternoon, everyone. So, good afternoon, everyone.
Okay, should I
Ankit,
share your screen?
yeah,
Your PPT?
yep.
Yeah, I'm sharing.
Okay. Yeah, Ankit,
Wait, I'm
is
sharing.
my okay?
Eh, Didipan,
Hello, Ankit, is it visible now?
Yes, yes.
Okay. So today I will present my topic on feature selection, that is sequential forward and backward selection. So, firstly, what are the features? So features mainly contain information about a target. Now, So generally, if we say if there are more features, but the better will be our discriminative power as there will be more information. So, but if we have limited training example or limited computational power, so it can lead to a very serious effect that is called the cause of curse of dimensionality. So in that case, in if we have a large number of features, then we have to select some very relevant features. So in order to avoid curse of dimensionality, so we use what is called feature reduction. Now there are two types of feature reduction. First one is the feature selection and the second one is the feature reduction. Now today the topic is about feature selection. So there are certain criteria that defines feature selection. The first one is that either improve or maintain the classification accuracy, that means, or simplify classifier complexity. And the second is that feature selection is just the optimization problem. So let us consider a set of features denoted by f and f dash b is prime subset, that means having relevant features. So there will be total twice raised to power n possible subsets that can be exhaustively searched, but that will be computationally prohibitive. So there are two way of searching. Actually, there are three ways of searching. They are called optimum, heuristic, and randomized. So today we'll discuss about two types of heuristic. Now, first one is called the forward selection. So in forward selection, we start with an empty set, add features one by one, and estimate the classification or regression error by adding each feature. Now, the second one is backward selection. So in backward selection, we start with a full feature set and try removing features. That means we drop the irrelevant features. Now, the feature selection steps are as given in the diagram. So you can see the step one is that we search the space of possible feature subsets. That means we provide the training data to that feature subset selection. So it search for the feature subset, and then that objective function defines whether the subset will be good or not. After that, the second step is that we we pick the subset that is the most optimal, or you can say near optimal, with respect to some objective function. And then the feature selection step are just I have said earlier, they are optimum, heuristic, and randomized. And there are two evaluation strategies. There are filter methods and wrapper methods. So basically, supervised learning, that is called the wrapper method, is used, which is mainly for training the selected subset and then estimating error on validation dataset. And the second one is unsupervised. That means filter method. In it, we simply look at the input only and then select the subset that has most information. So that's all. Thank you.
Is my screen visible? Hello.
Yeah, it's visible.
Good afternoon, everyone. Today our topic is feature selection. Before know about the feature selection, before going through the type of feature selection, but first we have to know about what is the features. Features are certain distinctive attribute or aspect or characteristic of an object which helps to identify an object from the rest. What does it mean that there in a cluster of objects we have to in order to find an object, the object has to have some distinctive characteristics which will be differentiate it from the others, from the rest. Then we have to know about the feature selection. When we talk about the feature selection is the process of choosing only those important features which will assist or help in the process of reducing the number of input variables that will help in predicting the object, what is the object based on the features. We can it doesn't mean that a large number of features will help in by improving the algorithm. In the contrast, it may cause problem in the selecting the describe the feature describe the object. The feature selections. When we talk about the feature selection, we have a large set of features, but we have to choose the subset of features we can the and it reduces the complexity of the model and make it easier to implement. There's mainly two types of feature selection approach. One is filter approach, other is the wrapper approach. The filter approach is fast in execution, but it a large number of sets, and which leads to the inaccuracy of the object. And the wrapper approach, its advantage is the accuracy, but it's slow execution because it is an iterative process. It goes through the goes to the object again and again. Our topics include the forward feature selection and that we start with an empty set. Then we select the best feature which will help in which will help in identifying the object. Then next in the next step it will add another, and it will go on the criteria of and we start with a predefined n number of then we try to eliminate the features one by one. It is also an iterative approach until the elimination is actually until observation until a substantial observation is observed permanent features.
Hello everyone, am I audible?
Yes.
Hello everyone, myself Fayaz Kochar, and today I am going to discuss related to feature selection. And let's start. Why we need feature selection (FS), that is to improve performance in terms of speed, predictive power, simplicity of the model, to visualize the data for model selection, to reduce dimensionally and remove noise. From this we can note that feature selection is a process that chooses an optimal subset of features according to a certain criteria. Overview, that is reason for performing FS may include removing irrelevant data, increasing predictive accuracy of learned models, reducing the cost of the data, improving learning efficiency such as reducing storage requirement and computational costs, reducing the complexity of the resulting model description, improving the understanding of the data on the model. Perspective, if we go then searching for the best subset of features, criteria for evaluating defined subsets, principle for selecting, adding, removing or changing new features during the search. Feature selection is of two types, that is sequential forward selection and sequential backward selection. Sequential forward selection, that is FFS, that is first the best single feature is selected, then pairs of features are formed with one of the remaining features and the base feature and the base pair is selected. Next, triplets of features are formed using one of the remaining features and these two base features and the base triplet is selected. This procedure continues until a predefined number of features are selected. Sequential backward selection, that is SBS. First, the criteria function is computed for all n features. Then each feature is deleted one at a time. The criteria feature is computed for all subsets with n minus 1 features and the worst feature is discarded. Next, each future among the remaining n minus 1 is deleted one at a time, and the worst future is discarded to form a subset with n minus 2 future. This future, this procedure continues until a predefined numbers of futures are left. Thank you.
Bandhan.
Hello,
Yes, you are
am I audible?
audible. Yes,
Okay.
yes.
Is my screen is visible? So today's topic is future selection, sequential forward, backward selection. So, so future selection is also known as backward selection. Future selection is the process where you manually select those features which contribute most of your prediction to the group or in which you are interested in having irrelevant features in your data can be accuracy of the model maximum non-based irrelevant features. Features that only confidence, filter method, and embedment. So this filter method has several types of your selection method and also known as single filter vector analysis. We calculate or we compute the values of each individual value. So instead of combining, we just calculate or we just measure the value of each individual value. So in that method, instead of finding the best variable, we find all the best combination of variables, join, evaluate, or variable subset. Second one is whoa and third one is so next is so this is an inbuilt variable and so we don't have to take any yes in embed method the decision are taken by previous sample or estimate content so it's very much inbuilt or automated and it's easy to use without one having to select or either so and control the sign for selection best thing and next is and
Bandhan, your voice is not clear.
hello.
Your voice is not clear, and also your screen is not visible. No, no. I think you have connected laptop also. Both from both will this cause the same problem. It will echo continuous.
Hello, Ankit. Can you share my PPT?
Yeah, I'm sharing.
Hello.
Bandhan, I think there is problem on your in network.
Hello, right?
No, no, no. Dibya, I am sharing your screen.
Okay. Hello everyone. Today our discussion topic is feature selection, sequential forward and backward selection algorithm. Feature selection algorithm is one of the core concepts of machine learning, which usually impact of the performance of our model structure. First, we know what is feature selection. Feature selection is the process where you automatically or manually select those features which contribute most to your direction variable or output in which you are interested in. Having having relative features in your data can decrease the accuracy of the model and make your model learn based on irrelative features. So how can select features reduce over fitting, improve accuracy, and reduce training time? Some features selection method are univariate selection, features improvement, correlation matrix with heat map. Next, move on the next slide. Uh, Sequential forward selection. Sequential forward selection start with empty set x is equal to 0. It repeatedly add most significant features with respect to x. Some disadvantage of sequential forward selection algorithm is one of a feature is retained, it cannot be discarded and nesting problem. In this algorithm, as we select the base single features is select. Next, a pair of features are from using one of the remaining features, and these base features are um, base features and base pair is selected. Next, a triplet of features are formed using of the remaining features, and these two base features and base triplet are selected. Next, this procedure will continue until the predefined number of features are selected. Next, sequential backward selection. The sequential backward algorithm, it start with whole set x is equal to 0. It repeatedly delete least significant features in x. Some disadvantage of sequential backwards selection is that sequential backwards required are more computational than sequential forward nested problem. In here, first and the criteria function is compute for all n features. Then each feature is delete one at a time. Next, it function complete all subset with n-1 features. Next, each feature among the remaining n-1 is deleted at one of the time, and worst feature is discarded to form a new n-2 subset features. And this procedure will continue until a predefined number of features are left. So thank you.
Good afternoon, everyone. Myself, Meghna Malik from MCA 5th semester.
Only 5 minutes left. So please.
Today, I'll be talking about feature selection. The need of feature selection arises as high dimensional data often contains irrelevant or redundant features, resulting in reducing the accuracy of data mining algorithms. It also slows down the mining processes and arises storage and retrieval problems. Feature selection is a procedure to find a subset of features that produces a better model for a given dataset. The types of feature selections are sequential forward selection algorithm and sequential backward selection algorithm. In sequential forward selection algorithm, the first best single feature is selected, then the pairs of features are formed using one of the remaining features and this best feature, and the best pair is selected. Next, triplets of features are formed using one of the remaining features and two best features, and the best triplet is selected. This procedure continues until a predefined number of features are selected. In sequential backward selection algorithm, first the criterion function is computed for all features, then each feature is deleted one at a time. The criterion function is computed for all subsets with n-1 features, and the worst feature is discarded. Next, each feature among the remaining n-1 is deleted one at a time, and the worst feature is discarded to form a subset with n-2 features. This procedure continues until a predefined number of features are left. Thank you.
Hello everyone, my name is Siponjoy Bodloy. I am from Integrated MSc 9th semester. Sharing my screen. I'm going to sharing my screen now.
Only 2 minutes left.
Am I audible?
Yes, sir. Yes, sir. You are audible.
Okay. So this can conclude today's session. And frankly, tell me whether this topic discussed is an every point clear to you or not.
Yes, sir.
Sir, no, sir. No, sir.
Ready?
Yes.
Kunja Butler. Hello.
Your voice is not coming properly. Well, no problem. In that case, you can message. You can message in the WhatsApp. So I hope that these things will help us. Actually, this will help when you guys will take this seriously and go for some searching. Okay, find out something new to that topic with some more practical examples. Right. So do that like that. Okay. After all, I have seen that your presentation is good. So we'll continue with the next session. I think Ankit, no one left now. Ankit.
Yes, sir. Yes, sir. Yes.
Okay. Okay. Very good. Thank thank you, Ankit, and thank you to all of you. We'll meet in the next
Oh,
session.
okay, sir.
Ripunjay, hello, hello. Go play he or he did